Right, so in this video I'm just going to have a look at a couple of examples of using de Moivre's theorem. So the first one I'm going to look at is a very simple one. We'll just take the cos of pi over 3 plus I sine pi over 3, and what we're going to do is going to raise this to the power of 6. So de Moivre's theorem then just tells us that we can just put the 6 here, multiply the angle by 6, so it's 6 pi over 3 plus I sine 6 pi over 3. And this will just give me cos of 2 pi plus I sine 2 pi. The 3 will divide into the 6 twice. So the cos of 2 pi, as we know, is 1, and the sine of 2 pi is 0. So we get 0i. So 2 pi is just simply, this is, sorry, I'll do that properly. 2 pi is just simply 0 degrees. This is 0 degrees here, or if you go all the way around here, you've got 2 pi. So, anyway, yeah, that's the first one, very simple example. We'll have a look at another one. This one just slightly more detailed. Let's take, we'll take a complex number in rectangular form. So minus root 3 over 2 plus a half I. This is in rectangular form, so we're just going to raise that to the power of 6. So we're going to use de Moivre's theorem to do this here. Rather, I mean, you can multiply this whole thing out 6 times, but you know, that's going to take a while to do. De Moivre's theorem makes it a little bit easier. So first thing we want to do is we want to convert this into polar form. So if we just draw a rough sketch here, minus root 3 over 2 plus a half I, you know, it's going to be somewhere up around here. So this is our complex number here. If I draw a triangle there, I'll call this angle here alpha, and we'll call this angle here theta. So first thing we want to do is find the modulus of this complex number here. In other words, the distance from here to here. So the modulus of this complex number is going to be the square root of minus root 3 over 2 to be squared plus a half squared. So if we do that, we get, let's see, root 3 times root 3 is 3, 2 2's here, 4. Half squared is going to be 1 over 4. So that'll just simply give me the square root of 1. 3/4 plus quarter is 1, so that's just 1. So the square root of 1 is 1. So, or the distance from here to here, if you like, is just 1 unit. So now we have our or, if you like. Now, next thing we've got to do is find the argument, or find the angle theta here. So the way we're going to do that again is we're just going to find the reference angle here, alpha. So to find the reference angle, I'm going to use tan of this particular angle here. Now we know that we went out here a distance of minus root 3 over 2. So root 3 over 2 is our absolute value, the distance here. And then we went up here a half. So if I get the tan of my angle alpha here, so the tan of alpha is going to be a half over root 3 over 2. Now I'm taking the absolute value here rather than the negative value. So that's going to give me, let's see, a half multiplied by 2 over root 3. So that's going to give me 1 over root 3. That 2 will divide into that 2 there once. Okay, so I can just look up, I know that the tan of my reference angle alpha is 1 over root 3. When I look up what angle will actually give me a tan of 1 over root 3, I'll find that alpha is actually, I think it's pi over 6. Pi over 6. Or 30 degrees if you like. So now I have I have alpha here as well, but I don't need alpha, I need theta. Remember, pi over 6 is this part here. I actually need this part here. So the way I'd work that out is, I'm just going to subtract. I know that this is pi here, so I would say pi minus pi over 6. So pi minus pi over 6. So that's going to give me 5 pi over 6 when I do that. If I just subtract those two fractions, I'll get 6 pi minus pi, so that will just give me 5 pi over 6. So I know that this angle here, theta, is 5 pi over 6. So almost there. So that's theta then is going to be 5 pi over 6. So now I have everything. I can rewrite the complex number in polar form. So let's do that. So my original complex number was minus root 3 over 2 plus I, no, sorry, that's minus root 3 over 2 plus half I. So I just put a half here and I here. And we worked out that that was, we were going to raise this to the power of 6. So we worked out that the modulus here was in fact 1, so it's 1. So it's going to be cos. My angle here we worked out was 5 pi over 6, so that's 5 pi over 6 plus I sine 5 pi over 6. And we're raising that to the power of 6. Okay, so we're just going to use the Movres theorem to do this. So I can ignore the 1 here. So I can just write down cos 6 times 5 pi over 6 plus I sine, again, 6 times 5 pi over 6. So I can see that the sixes will divide into each other. So I get cos of 5 pi plus I sine 5 pi. Now, to work out the cos of and the sine of 5 pi, I know that you know, if I start here and I go around once, I've got 2 pi. Again, I've got another 2 pi, so that's 4 pi if I go around twice. So if I go around once, that's 2 pi. Go around again, I've got 4 pi. So halfway around here is going to bring me around to 5 pi. So really what I need to do here, in fact, is get the cos of pi plus I sine pi. 5 pi is actually pi here. I go around 2.5 times, so I end up here at pi. Now, if I take pi then as my angle and work that out, I get cos of pi is going to be minus 1, and the sine of pi is going to be 0, so I get 0i. So this here is my answer. When I raise this here, root 3 over 2 plus half I to the power of 6, I get minus 1 plus 0i. And that's it.